Okay, thank you very much, Sarah. So can I just check you can hear me and see me nicely? Is it? Have I
Yep,
managed
it's perfect.
things good? And thank you very much indeed to you and Rose for inviting me to talk. I'm really enjoying the format of the conference and all the lively and really interesting discussions. So I put this title on here, Sarah, and of course I can't really do it justice, but I thought it might be nice to make some conversations, because of course when we're finding raw materials, it's the manufacturers that we're really trying to reach. That's what we're doing, is producing raw materials for people to make things, and more they're interested in where the stuff is actually coming from. And so I just want to talk about some of the things we've been doing as geologists, because we are there right at the very start, and what can we do to help make sure that the things we make start off their life in a responsible way. And of course, as we need a wider range of elements and more mined materials than ever before in order to decarbonize, as you can see this really pretty graph that everybody uses from Volker Sepp and co, there are lots of nice jobs for geologists to do, to go out and think about the geology of rock types that we haven't been able to research so much for ore deposits anyway before. And that's lots of nice minerals and rocks to look at and to try to understand them better and make new geological models. And of course, what we need to do now is not just simply go through this process of finding it as geologists, working out how to mine, how to do the mineral processing and the extraction, but we need to put this everything we do in this cocoon of environment and social responsibility, which is what everybody's been talking about this week. So we've been doing some work particularly on the rare earth elements, and I'm going to show how we are trying to kind of join up some of these issues. So this diagram here, I don't know if it looks a bit complicated when you first look at it, but here I've put the geology at the top. So this is what we would be looking at in making geomodels or doing the first stages of exploration. But of course, although we often talk about behaviours when we're thinking about responsible sourcing, there's an awful lot of geological characteristics that really affect directly how well the minerals will process, so how much waste there might be, how much energy will be used, and therefore what will the carbon footprint of the operation be, how much water, of course. Is it a big low-grade deposit where you're going to have to move loads of rocks and make a big hole in the ground? Is it a small high-grade deposit where you can get a lot of material out for a small hole in the ground? Is it not a hole in the ground at all, etc., etc.? And so I think that a lot of these characteristics really do deal with what are measured later in responsible mining indices, and so we can start to think about that right at the beginning. And here's my Zoom montage, if you like. So my Zoom canvas of alkaline rocks and carbonatites. And then as geologists, this is the world that we live in. And I think Catherine Goodenough has already given a very nice comparison of some of the different ore deposits for rare earths and their different characteristics. And of course, we could all talk for hours and hours and give you a whole hour-long lecture on process mineralogy of rare earths or potential wastes from rare earth deposits and things. But that's no good when we come to make geomodels. We've got to somehow get all this beautiful Zoom canvas and hours and papers worth of information into really short, sharp indices and measures that can go into our geomodels. And so this is for our high-tech Alcar project, a Horizons 2020 funded project. We were making a mineral systems model on that with Graham Banks at Gaius in Denmark. And he made us, he was very nasty to us, he stopped us with that big Zoom canvas and got us right down to thinking about what are the risks, how do the rare earth minerals processing characteristics affect the favourability of the deposit going forward in this mineral systems approach. And so that links nicely to the previous talk looking about the risks in table 1 and so on. And so we have to go right from all of this huge amount of information. And the only way we could do that was to get all of us together, consultants who are doing it for real and the academics, and actually try and get things down into just these little boxes here. And you see we've got favourable, encouraging, you'll recognise these indices, neutral, as a risk, and then questionable and unfavourable. And Sarah, because this is going to go up on the website afterwards, I didn't want anybody coming, and it's not formally published yet, I didn't want to get sued by people not wanting their seeing their deposits in this bottom category. But of course, with new things like this is rare earth deposits here, particularly looking at alkaline rocks and carbonatites, and questionable for these odd things that are high-tech elements that are new things that we haven't mined so much before, is actually pretty good. And when you do these risk assessments, you'll find that a lot of stuff comes straight out in there because it's just a different mineral rock combination that hasn't been looked at before. And so you can see on here something like bastnasite, which is a mineral that's one of the most common ores of rare earths, for where it's been mined for years and is well known in calcite carbonatite, that would get our green. And then where people are developing totally new things, that would come down here, or right in the unfavourable if nobody's actually done it before. And this is really useful. You can plot that up with mineral systems, or you can immediately get some idea very quickly within a couple of minutes of where your deposit, if you're looking at a new deposit as an exploration geologist, sits in there. So that's condensed, I would say, reasonably well. And then we're trying to put this into a new kind of model along the lines of the kind of models that you'll see in textbooks. And I've got here Mike Labar, 1977 model for an alkaline system and carbonatite. So that's a drawing. I should put a little hole on there, and then you could have your mine, Sarah. Actually, the mine would be down here somewhere. So maybe that's my effort I'm going to send in. And what that translates to today is 3D PDFs. So the British Geological Survey will be producing these. They're not available yet, but Charlie Beard, together with Catherine Niemer and all of us on the High Tech Alcarb project, have been making these. And here's all the geology. I think I'm showing that with the mouse now. But how do you get your environmental and even through to social characteristics on that? And we found that was actually really hard to condense the geology information and get this other stuff. And so we resorted to these pop-up boxes. This is a lot of this is Ema's handiwork making this nice. And so on here you can see the size and grade, and this gives you some idea of the amount of material you have to use. So we've got it doesn't say this will be a responsibly sourced rock if you mine it or not, but we have been able to get some characteristics on. So here's the kind of minerals that you would find from that Zoom montage has gone right down, and our risk assessment just tells you there whether it's in development, like this one here, for eudialyte, whether it's well known and mined already from different places like xenotime or pyrochlore or monazite. And so we're beginning to be able to put some information on here. And I'd say it's not perfect yet. We haven't been able to fit in radioactivity. And when we do this for carbonatites in a few weeks' time, then we want to be able to put that in, because that's the main social issue, I would say. We're writing about that at the moment, is whether carbonatites and alkaline rocks will produce radioactive ores. And that's what we find people are most interested in, but we haven't got on that on this pop-up yet, but hopefully we're getting there. So quite difficult to keep the environmental and social in there when you've really got a constrained way to show your information and only a small amount of space. So now I want to just show another way that we've been moving environmental and social aspects, especially the environmental ones, into the exploration stages. So our geomodels would be down here. This is what the geologist would read when they first get interested. So we wanted to be able to assimilate those things in just a couple of minutes. But then what happens as you go through these stages? And we've been looking at life cycle assessment as a technique, because coming back to this manufacturing theme, big time, that's what manufacturers and retailers and everybody is using. They're using the LCA technique to assess the environmental performance. And mostly in mining, there's not very much of that done, but if it's done, it's on working mines. And what we've been doing, and this was Rob Pell, who's already spoken at this conference with Minvera, did for his PhD, was to work out how to move this LCA right forward in the process, so that during exploration as geologists we can get one of these LCAs done and look ahead to what the environmental performance of a deposit will be. And here is one that was done, and this was done by Rob, and it was done from a pre-feasibility study, NI 43-101. And so these weren't our numbers. So it means that any investor, anyone who's interested in a deposit can go to these technical reports, and it's likely even at pre-feasibility stage, there'll be enough information that even if the company hasn't done it, you can do it and have a look at the environmental performance that's likely for this deposit. And this very complicated graph has kilograms of CO2 on the y-axis, and then the 45 years of projected mine life along the x-axis has all these bubbly numbers and graphs, and this is showing all the aspects of mining and processing and its contribution to the CO2 that will be produced from this mine if and when it works. And so first of all, anybody from outside can assess it. If this was done by the company, they could present it themselves rather than waiting for somebody else to do it. And when it's done with the company, of course, this is an ideal opportunity to have a look at what the environmental performance will be. And then at pre-feasibility, you've built precisely nothing, of course. There's oodles of room to go and modify what the mine will look like, what kind of power source you'll use, how you'll recycle things, and make sure that this environmental footprint is kept as low as possible. And I think that's really where LCA comes into its own. It's a lovely way of looking forward and being able to design your mine to fit an environmental footprint as well as an economic need that you have to make money. And so using LCA, this is a way in which we can join up from here we are in raw materials. And I really like this diagram from the Ellen MacArthur Foundation, because look, it even has a line on this particular version between mining and the rest of the virtuous circle economy. And we're completely divorced from these people. And so this is the next thing we're looking at. And LCA really helps with us with that, I think, is not to be divorced from the rest of the manufacturing cycle. We need to be in there. Instead of seeing school textbooks and things and say, you know, we need raw materials for manufacturing, but mining is very environmentally damaging. What about seeing if we recycled more? What a pity that we wouldn't need to mine so much anymore, because mining is so important for sustainable development of communities. And so that's our challenge, isn't it? Is to find ways to join up and be seen as raw materials providers. And I think we need to make best friends with the recyclers and use things like LCA and sustainable development to do that. And I just put this slide in at the end to show that it's not just thinking about Africa and Australia and Canada. As we've heard in some of the talks at this conference, we're doing it right here in Europe. And that's a great challenge when it's on your doorstep, even in Cornwall, right on my doorstep, is to think about how we can produce those new commodities like lithium and so on in the most environmentally and socially responsible ways. So here we go then, there's my summary of roles for geoscientists to get as far as possible in not only producing the technology raw materials we need, but in really helping manufacturers achieve responsible sourcing. Thank you very much.
Brilliant. Thank you so much, Frances. Absolutely fantastic, as always. So massive round of applause from all of us on the far end of those microphones. Now, as per usual, we do have a range of questions coming in through the different channels. And the first one I'm going to put to you, if I may, comes from Karen Nash, who you will see she's asked some other questions as well, and she's very much an expert in this area. Karen asks, given that the environmental and social studies are costly and privately funded by specific operators, how difficult has it been or will it be to then obtain site or deposit specific information that will then be freely shared in your models that you've discussed here?
Oh, that's quite complicated. So she said, given that they're costly, how well? Of course, if you looked at that Bear Lodge graph, that was produced from a NI 43-101 report, and of course they're brilliant because they're available publicly free. So once the company was just doing its normal work to produce the NI 43-101, it didn't do anything special in that report at all in order that we could do the LCA. So I think that's an important point, is when you get to that level of technical report, we could immediately take that. I think if I could just answer a slide, I don't know if this is quite the right question, you might have to ask it to me again. But if you that took Rob Pell in his PhD a long time to do that LCA. Garbage in, garbage out, of course. It may look like numbers, but if they're the wrong numbers going in, they can get anything out. And then people believe it because it's a number rather than just somebody saying something. And so what really we need, and I know this is something that Rob's looking at, is how do you get a nice LCA light, if you like, technique that produces useful numbers that can be compared with each other, but won't cost junior exploration companies and things so much money that they can't possibly do it. So in order to do that kind of modeling, people are already producing the right information, and then we just need LCA parameters set up so that they can actually do that kind of modeling without having to employ a consultant for months and months.
Great, thanks, Francis. And just, I guess, to build on that, and perhaps ask the second part to Karen's question here, which is saying, seeing as it's often, say, those junior mining companies who are paying for the likes of the life cycle analysis to be done, what happens if actually during that analysis you don't get the right answer? I.e. it throws up things that perhaps you don't want investors to know about necessarily. And this also brings on some of what I think Ed was talking about with regards to the extent of uncertainty that you can often have, especially in a very young project. Do you have any comments to that?
You made that lovely point, didn't you? Well, I guess well, we did actually some modeling with a company, and it showed that the carbon footprint of their deposit, if they went with the energy source they thought they were going to use, which was the big thing that the country wanted everybody to use, that would actually be quite high compared with other proposed mines. And they just went back and they just changed the way they were using their energies, and they didn't have to go and mine somewhere else kind of thing. It didn't kill their deposit. It just modified the way that they were actually providing energy for the deposit. And so although you know, it didn't show them immediately that they were going to be the best mine in the world. It meant that before they'd spent a penny on anything, because they were still at pre-feasibility stage, they could make modifications. And of course, that's really cheap to make modifications at that time, rather than build a mine and then somebody comes along and does that kind of analysis and says, well, people aren't going to buy from your mine because, and then you've got multi-millions to spend. Yeah, do it early. If it's bad news, find out the bad news early, and then you can probably mitigate it in some way.
Yes, also known as proactive risk management. Which... Brilliant. And thank you very, very much, Francis. And for those of you who have been tuning in to this conference during the week, you may remember Ruth Annington's talk from yesterday morning, where she was looking at this cradle to grave approach, or bringing some of those aspects in with regards to quarrying. So that talk, I'll signpost you back to that one from yesterday as well, because I think it complements a lot of what Francis has been saying here today, obviously together with Rob Pell's talk from yesterday afternoon as well. So brilliant. Thank you very, very much, Francis. Massive round of applause from those of us on the other end of the phones, etc.